Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Rat Run 30 Star Rats by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Aim of experiment. F and P must both reach the cupcakes by finding a path through the maze. The paths must not visit any cell more than once, cross themselves or each other, or pass through any thick maze walls. The paths may not share cells except for where they meet at the cupcake cell. As well as moving orthogonally, they may move diagonally if there is a 2x2 space in which to do so, but they may never pass diagonally through a round wall spot on the corner of a cell. So, as an example, this rat, we'll label, I don't know which one. Maybe we'll make it P. P cannot go this way. It goes through a wall. Cannot visit any cell more than once. Cannot cross the other rat's path. Cannot cross F's path or itself. And again, cannot pass through thick walls. If F were to go like, well, F is sort of required to go this way, but P. P could go this way, and then P could go that way. That is allowed because it can go diagonally in the 2x2 space that it allows for it. What she could not do, though, is something like this, because she's trying to go diagonally through a round wall spot on the corner of a cell, and that's not allowed. And that includes this. That's not allowed either. So that's how these paths work. We have booster cells. There is one booster cell in every row, column, and box. Got something stuck in, well, just itchy or whatever. Something went down the wrong pipe. So there's a booster cell once in every row, column, and box, and each contains a different digit. So that means every digit must be different for every booster cell. Excuse me. The value of a booster cell equals its digit plus its row number plus its column number. For example, if row 7, column 3 is a booster cell and contains a 6, it would have a value of 16, which is 7, which is its row number, plus 3, which is its column number, plus 6, which is the digit in that cell. So that is what booster cells provide. We have black currants, or that's how I pronounce them. They're either supposedly called black currants or something like that. But I like pronouncing it the Frenchified way. It's not really French, but that's just the way I said it. Anyways, if two cells are joined by a black currant, then the value of one is double the value of the other. So, for example, if this were, say, a 4, this would have to be a value of 2 or 8 here. And that's an example of how the black currants work. We also have starfruit, where the sum of the two values joined by a starfruit is always the same and must be deduced. So the value of these two cells is equal to the value of these two cells, which is equal to the value of these two cells, which is equal to the value of these two cells, which is also equal to the value of these two cells. That is interesting. Test constraint. In this experiment, both rats visit the same number of cells. Interesting. And the sequence of values along both paths are identical. For example, if the first 5 values visited by F are 7, 4, 12, 3, and 8, so say this was 7, 4, this was 12 in value, 3, and 8, then the same must be true for Finks. So this would then be, for it to be value of 12, it would have to be a booster cell. So say we had, then this would also have to be 7, 4, 12, 3, and 8. And those are all the rules. So the sequence of values along both paths are identical. So that means the value of each cell on the path must be the same. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, P has a very strict path on the first 10 cells. F, though, can go either this way or go this way. So, interesting. The value of the booster cell, which P has to go through, must equal the value of the booster cell that F must go through. The minimum value possible for P's booster cell has to, maybe this isn't the best path. Let's start with the stars. In the stars, these must add up to the same value, and these must add up to the same value. Well, this value is going to stay the same for both of these sets, so therefore these must be the same value. The only way that they can be the same value is if one of them is the booster cell. So that means the remaining digits in this box and column cannot be booster cells. So these cannot be booster cells, and these can't be booster cells. So the value of the stars has to be 2 unique digits added up. Okay. This is not a booster cell. One of these two is. Okay. Now this, if it's added up, that would be row 1, column 4. So that would add 5 to something. This, if it were a booster cell, would be row 3, column 4. So that would add 7 to the booster cell. Interesting. This obviously cannot be the value of a 2-digit number, because if we had to have a 2-digit number, this digit would have to also be a value of a 2-digit number, which is not possible without a booster cell. So this must then be 1, 2, 3, 4, 6, or 8 as a value, which means this also must be 1, 2, 3, 4, 6, and 8. Okay. In the first 9 steps for the rat, there must be some booster value. Because the minimum here would be 7 and 7, which is 14 plus 1. If you go this way, it increases by at least 1 or 2. If you go this way, it increases by 1 or 2. If you go that way, it's 1 or 2. So this cannot be booster cell, because if it were booster cell, this would have to match. And this booster cell is 9 plus 9, which is 18, plus 1, which is 19 at most. This would be 4 for the row and 1 for the column. So I guess part of it is trying to ask what can be booster cells, right? You have 9, 9, and 1 as the minimum for this value if it's a booster cell. That's 19. This could technically be a booster cell. It's 4 and 1 in value. Okay, so this cannot be booster cell. This could be. This would be 8, 9, and 1. That's 18. If we went this way as F, let's check both. Okay, so we check both. Well, this one is the one that's increasing. Actually, let's just go this route and see if we can ever get a booster cell that matches this. So if we try going this way, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the most this can be. Okay. Can it be there is kind of the question as the booster cell. Okay, so going this way, this is probably the most you're going to get. So again, this is 19 at most, or sorry, 19 at least. This is 4 plus 1 plus 9, which is 14 at most. So this can't be booster cell. What about this? This is 1 plus 8 plus 9, 18. These would be, so this would be at most 5 plus 1 plus 9, which is 15. So this cannot be booster cell. This is 1, 7, and 9, 17. We tried going here, that's 6, 1, and 9, which is 16. So this cannot be booster cell. This is when we can actually have a booster cell value. But if we're going this way, the problem is 1, 2, 3, 4, 5 would be also 1, 2, 3, 4, 5. So this would guaranteed cannot be the same digit as that. So if this is not the booster cell, then it must be, sorry, then F must go this route. So either this is going to be booster cell. I guess this, no, that can't be booster cell. If this were booster cell, it'd be way too big for this as a normal digit. So this would have to be the booster cell here, if that were the case. So if F is going this route, this has to be the booster cell, which means none of these can be booster cells at all. If F is going this route, the question is, can this as a booster cell add up to the same value as that? So let's try. Obviously, none of these three work. This is 1 plus 1 plus 9 at most, which is 11. This is... Can that actually work, actually? Let's try that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If this is so these obviously can't be the same digit. So if this was booster cell here, it has to be booster cell, first of all. But the problem with that is this would be 8, which would be the row number, plus 1, which is the column, plus 1. This would be, as a booster cell, 10. This would be non-booster cell, which would not be 9, or which could not be 10 or above. So F cannot go this route. So she actually does have to go this route here. So F actually does have to go this route. That's interesting. She has to go there. These are non-booster cells. This becomes 2 and 1. This is 1 and 1 plus 9, which is 11. That's not the same as that booster cell there, because that's 1, 7, and 8 at minimum. 1, 8, and 8. 1, 1, 2. That's not going to work. Booster cell here. So 1, 2, 3, 4, 5, 6. This is 1 and 3. That's 4 plus 9. 13. This is 8 as a row, 9 plus 1, which is 18. So no. Can this be... Well, the problem with this being booster cell is you have to have a digit in a 1-to-2 ratio with it also. Anyways, this is 7, that's 7. So one of these three is booster cell, which eliminates booster cells in the rest of the row. This would be 7 plus 9, and it'd have to be in a 1-to-2 ratio with another digit. So 7 plus 9 is 16. Plus 2 could work, so that would be 18. But this would be 1, 2, 3, 4, 5, 6, 7. That would have to be a booster cell of 2 plus 3. That's 5, 2, 3, which is too small. 2, 3, and 9 is 14. So cannot match 18. So this cannot be booster cell. Can this be booster cell? You could potentially go to 3 and 3. That's 6. Plus 9 is 15. So I don't think this can be booster cell. This would, if booster cell, that would be 7 and 8, which is 15 already, plus 1 is 16. So this cannot match booster cell. So this must be the booster cell here. Okay. So you could do... So booster cell could be 3 plus 3 plus 9 is 15. 4 plus 3. So if we go here, so if we do something like going like that to there, or that to there, then this could be booster cell. So one of these two, I think, has to be the booster cell to match this. So again, 7, 7, 1, it's 15. It could also be 16 here. If we go here, that's the largest this booster cell could add. So that would be 4 plus 3, which is 7 plus 9. So this is guaranteed to be 1 or 2 here. So this is the most it could be. It could be 16, and that could be in a 1-to-2 ratio with 8. So that could work. But this could also be booster cell with that being 9. So this could be booster cell with that being 9. What it cannot be is booster cell here with a value of 8, because the booster cell here would be 3 plus 4 plus 8, which is 15. But 15 is not in a 1 to 2 ratio with any value that we can create. So we have to have, if it's here, it has to be value of 9 as a booster cell. It cannot go here because this would be too small. 3 plus 2 plus 9 is 14 at most. So one of these two cells is the booster cell here. So it could go like something like that, or something like that. So one of these is a booster value. And if this is booster value, it must be 9 because it adds up to 15 at most, and this adds up to 15 at least, and they must match. If we go here, this also must be a 9 because we cannot have 15 be in a 1 to 2 ratio with another digit or any value that we have. So we're guaranteed this is 9 and one of these is a booster cell. So the rest of the row cannot be booster cells. Interesting. We eventually do, though, have to get into that position. We don't know. So we have to go this route. Guaranteed. Okay. We don't know if any of these are... So this has to be the same value as that. Okay. Interesting. So here we have 4 digits guaranteed in box 2 to add up to the same value. So obviously the value cannot be 17, 18. It cannot be 3 or 4. It can't be low digits either. 5 doesn't work because this must only add value as one of these cells. Excuse me. And it has to add at least 5 in value. So 5 plus a minimum 1 or 2 would add up to 8. So can this add up to 8, 8, and 8 here? I don't know. So you would have to have 1 and 2 in this scenario. So I guess you have 1, 2 here, and then 7. Oh, but that doesn't work. Right, this has to be essentially... it can only be an even number. So it'd be 2 here, and then 1 here, so that's 6. And then you have 6 there. So you have 2, 6, 6. That would force this to be 3. But that, okay, so then that cannot work for 8. Can it be 9? Possibly. So the sum of the stars is 9 and above. And 9 up to 15 is possible. Okay. Remaining booster cells in column 7 cannot be... The cells can't be booster cells because we have a booster cell there. This obviously can't be 1 and 2, so this has to be either 2, 4, 4, 8, or 3, 6. So as the 7th digit, okay, you could be 2, 3, 4, 6, or 8. and you cannot be, you could be a booster cell. So that would be 2 plus 3. So 2, 3, 4, 6, 8 is possible as a value. With booster value, it would be 2 plus 3, which is 5. 5 plus 1 adds up to 6 in value. 5 plus 3 also. So this is guaranteed then to be 1, 2, 3, 4, 6, and 8. Okay. What happens if this is a booster cell? Can it stay? Okay, so what would that be? It would be row 9, column 5, that's 14. Then you add 2 or 4 to it, which would add up to... So if this is booster cell, it can only add 2 and 4 to the boosting. So this is, no matter what, 1, 2, 3, 4, 6, and 8. Same with this. This is also 1, 2, 3, 4, 6, and... No, that's not true. Oh, wait. Well, we know one of these two is a booster cell. If this is booster cell, obviously this has to be... Well, the thing is, this is always guaranteed to be on the path. So if this is booster cell, it would be 1, 2, 3, 4, 6, and 8. Wait. No, if it's not booster cell, it would be 1, 2, 3, 4, 6, and 8. If it's booster cell, it's 9. Wait. Hold up. That can't be booster cell. If this is booster cell, it would have to be 9. So this would be value of 16. This would be value of 16. 16 but plus 1 adds up to 17, but we already have a 9 in the box. So therefore, this would have to be 8 and 9 there, here, to add up to 17 without a booster cell. So that's not going to work. So this cannot be the booster cell. It must go to one of these two, and then this has to be the booster cell, and it's a 9. So this is a 9. This must match the 10 here. So this is not booster cell because of the booster cell in the row. This can't be, none of the rest of this box can be booster cell. None of the rest of this column can be booster cell either. This then has to be booster cell here. This cannot be booster cell there. One of these two is booster cells there. So this must be plus 4 plus 1. And these must be then the same values. So, plus 4 plus 1 is 5. And that must equal the same value as that. 5 plus 1 is 6. 5 plus 2 is 7, but 7 cannot be in a 1 to 2 ratio with another digit. 5 plus 3 is 8. So this could be 6 or 8. So if we do know one of these is guaranteed to be 3. If this is 1, and then this matches, it has to be 6. 6 is in 1 to 2 ratio with 3. So this could be 3, that's 3. This then must match this cell here, and it cannot be a booster cell, so it's 6 or 8. This is not booster cell, so all of these must match all of these. So this is 2, 3, 4, 6, 8. So this is 9 here. That's 9 plus 3 and 3 is 15. So that matches booster cell here, which is 1 plus 7 and 7. Okay, so none of these can be booster cells. So one of these matches 2, 3, 4, 6, and 8. That means this is going to have to be 4 with 2 or 8 because we are guaranteed one of these two matches that cell, and then this cell matches that cell. So this is the 7th, 1, 2, 3, 4, 5, 6, 7th digit on the path, as is the 7th digit here. So this is in a 1 to 2 ratio with one of these, which is in a 1 to 2 ratio with another digit. So the 8th digit must be 2 or 4, which is in a 1 to 2 ratio with 2, 4, or 8. So this must be 2, 4, 8. This has to be essentially a 2, 4, 8 triplet in this thing, because one of these is going to be 4 in the 1 to 2 ratio with 2 or 8, or yes, and then the other one has to be in the 1 to 2 ratio with that. That means the remaining digits in this box 1 are 1, 3, 5, 7, and 6. 1, 3, 5, 6, 7, which are path 2 through 6 here. So this must be, it cannot have a, whoa, we have to have a 1. Hold up. Oh, the 1 cannot be here. Okay, so then this can't be 2, 4, and 8. It has to be 1, 2, and 4, because 1 cannot be on this path. So therefore, this must be 3, 5, 6, 7, 8 here. So this is 3, 5, 6, 7, 8 here, which eliminates this cannot be 8. It's 2 and 4 as a pair. So this cannot be 8. It's 1, 2, and 4 here. Therefore, one of these is going to be 1, and it has to be in a 1 to 2 ratio with 2, which means this can't be 2. This must be 4 here. So that matches this digit here. So that's 4 there, which makes that a 2. Remaining digit in box 9 is a 9. So this must be a 9 in value. It could be a booster cell, though. So 3, 5, 6, 7, 8. Again, we have 9 up to 15 as potential star values. Well, actually, hold up. This is, yeah, so that works. You could, to have 9, it would have to be 1 here. So this must match the 2 in one of these spots. We don't know which. This obviously is a 9, or if it's a booster cell, that's row 4, column 1, which is 5 plus 4. So this is 4 or 9 there. If we go here, then this would have to go, well, not necessarily. This path, though, could go to any of those 3, so that's fine. Remaining digits in row 7, we have 3, 5, 6, 7, 8, 9. No 9 here because of 9 in the column. We don't have anything else, really. This is 1 or 2 here. 9 is here. Okay. Where do we go to next? Okay. So if this is non-booster cell, these two digits must be the same. Okay, what digits can this be? Maybe is another question. It could be 1. 1 and 8 satisfies that, and that would be 3 and 4 then. So we could have 1. Can we have 2? 2 and 8 does work. That adds up to 10. You could have 2. You can't have a 3 here. You can't have 4. Can you have 5, 6, 7? You could even have 9 here. Oof. Okay, so that's not that restrictive. Right? 9 and 6 add up to 15. Um... Wait, what happens if this were the booster cell? That would be 8 and 6, which is 14. 14 plus 6 at minimum is 20, so this cannot be booster cell. Okay. So this must match that digit. This must match that digit, which means those two digits have to be in column 5, be here. So this will make it, we'll make this A, that match, and Z add up to the same sum. A has to be one of these digits here. Interesting. Okay. Can F go here or here? The answer is no. Because if F goes here or here, that means P cannot go here because they would have to be the same value and they are not on booster cells. And right. So F cannot go to either of these cells here, which means F, because if F goes to here, we know Z and A match these cells. So if P goes this way, the only way that F can go is that way also. But if P tries going that way to match one of these two, the problem is they are in the same column, and therefore it would be a repeat. And if F tries to go that way to match Z, well, then P has to go this way, guaranteed. So either way, F has to go this way, P has to go this way, guaranteed. So F goes that way, P goes this way. And then F could go here, or F could go here. So if F goes to one of these 3, P has to go down there. Or P could go here with one of them being, well, that's not gonna, one of them being booster cell, that's not gonna work. Because the booster cell here is going to be a large value, and you have a singleton here. So these are basically digits of value. This is either 6 or 8. Can F go here then? If F goes here, the problem is it's also the same value as A. And there's no way a booster cell here can add up to 6 or 8. This is at minimum 8 plus 5, which is 13 already. So F cannot go this way. F has to go to one of these 3, which means P cannot go to a booster cell, has to go to a normal cell value, which is here. Because it can't be here, if as a normal cell value, because then these would be duplicated here. And therefore, this is normal cell value. This must then be a booster cell, which eliminates booster cells in the rest of the column. And P cannot go to the booster cell here. P has to go to one of the ones that are not the booster cell, while F can go to here, 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 or here even. Interesting. Hmm. This is obviously 1, 2, 3, 4, 6, and 8. Oh, this doesn't actually have to be 1, 2, 3, 4, 6, and 8. If this is a booster cell... Okay, well... No, if this is booster cell, that's 9 plus 5, which is 14. But we don't have a 9 available in this column anymore. So it can't be 9 and 18 here. It can only be 8 and 16. So that's why this is still 1, 2, 3, 4, 6, and 8. Interesting. Okay. So we need to have A and Z be here. One of these three is booster cell, but we don't know which. So A and Z are both here. Let's just mark that down. I'm going to pause because I need to go to the bathroom. I'll be right back. And I'm back. Let's continue. Okay. So one of these three cells must match that cell there. So let's mark that as, I don't know, Y. So Y has to be one of those three, which means it must be one of those three. What happens if this is a booster cell? That's row 4, column 6, so that's 10. So that means this digit must be... Oh, this doesn't have to... Okay. This doesn't have to be 1 through whatever, 6 and 8. It could actually be a lot of things. So 4 plus 6 is 10. So it could be 12, 14, 16, or 18 here, along with the additional 1 through 3. So this could be 1, 2, 3, 4, 6, and 8 still, but it could also be 7 and 9 here. So the only one it can't be is 5. That's interesting. Can it, though? Okay, so say this was booster cell. Oh, yeah, it could be. Then this would be 9. So if this is booster cell, this would have to be 9, so that can't be 9 there. That eliminates 9. But if this is not booster cell, this could still be booster cell there. Hmm. Hmm. This is pretty broad, though, about where this can go. So we know P goes through one of these paths, and then it matches one of these 3 cells. It could, heck, it could even match that technically, right? You could go that path and then there. Hmm. Um, and then it could actually double back out and then go this way. That's potentially possible. So P has to go to one of these two, then goes through here, because this digit as a booster would not be able to be matched on F's path. So... Hmm. What else can we do? Mm, 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 mm. Hmm. So P is going to have to go to one of these 2 cells here. So going to be going here, then to here. Oh, you can't go down to here. So then F has to go to one of those 4 cells there. Hmm. Yeah, that's all we have. Hmm. Can this actually be 15? If this is 15, that means these 2 digits must add up to 15. So this must be 7 and 8, which would force us to be 3, 5, 6, which would force this to be 1. So that would make 6 there. That would be 3. That could work. 6 and 9 with 1 plus 4 and 1 is 6 plus 9 is 15. So this would have to be a 7, 8 pair. This would then be 6 and 9 there. That could work. Interesting. So, unfortunately, that seems to work fine. To add up to 9, remember we tried with 3 and 5. That just didn't work with this way, the way that this black black courant, or black courant works. So you could have 3, 6 here. And this would be 8 and 1. So that would be value of 9. This would be 4. Because if this were 3, 6 as a pair to add up to 9, obviously you can't have a 3, 6 pair here because that would eliminate all possibilities for that cell. So it would have to be 4 and 8 here. You'd have 1, 8 here, and 3 there. So these would add up to 9. Hmm. It would be 2 and 7, because it cannot have 1 and 8, cannot be 3 and 6, can't be 4 and 5, because this is 8 and 4. So in this scenario, it's 7, 8 here if it's 15. It's 2 and 7 here if it's 9. What about 10? 10 would force us to be 3 and 7 as the only possibility. So we'd have 3, 7 here. This would be 5, 6, and 8, which doesn't really tell us too much. So this is value 6 or 8. It cannot be... It would have to be 2, 8 here. So we'd have 2, 8, 4. This would be 3. So to add up to 10, this would cannot have 2 and 8. No 4. 6. No 3, 7. It would be 1, 9. So you'd have to have 9, 1 here. So that also still works okay. So 10. 12 is... Okay, so we have 14 potentially as a possibility. That would force 6 and 8 to be here. 3, 5, 7 there. Huh. So 6 and 8 there, 3, 5, 7 there. That would be 1, so therefore this would be value of 6. 6 and 8 would be there. This would then have to be 5, 9, which does work. Adding up to 14. Okay. I don't know if going down this path is the best way then. 13, 11 are very open-ended. 12, I think, has to be 5 and 7 here, which means this is 5, 7 here, which means this is 3, 6, 8 here. That makes this 1, so this is 6. So 12 does not work, because I would have to have 6 in value here and 6 in value here without the booster cell, and therefore it would be a repeat digit. So 12 doesn't work. So we have 9 still works fine, 10 works fine, 11 and 13 are probably going to work fine, 14 and 15 both work fine. Okay. The thing is, this could very well still be a valid booster cell, because it's only 5 plus 2, which is 7 in value. Uh, 7 plus 3 plus 1 is 11. So how do we attack this next? I was hoping that this would provide more clarity, but it didn't really. Oh, what are the possibilities then? Okay, so we do have 8 and 6 for 14. So these two digits must be the same as these two digits. So that means these two digits cannot be here, cannot be here. So they're guaranteed to be 2 out of the 4 digits here, but that doesn't really tell us very much. Hmm. Again, if this is 9, it's 3, 6. Which makes this 8 and 1. This is then 2 and 7. I mean, that seems fine. Remaining digits of column 2. We have 3 through 9. So that doesn't really help us much. This can't be 9 because of 9 in the row. Remaining digits of column 3. We have 1, 2, 3, 5, 6, 7, 8. Okay. That's not too helpful either. Hmm. Uh, hmm. Hmm. Okay. To add up to 9, it cannot be 3 and 6 here. So it'd have to be 1 and 8. To add up to 10, cannot be 4 and 6 here. So it has to be 2. 12 is not valid. 14 does work. So if this is 14, this is 6, 8 as a pair, which means 3 has to be here. Okay. So for 3 and 6, becomes 4, 8. So 3 and 6 could be there. I don't think we have much information about that. If this is 3, 7, and 8 here, adding up to 15, this is 3, 5, 6, which makes this 1, so that's 6 in value, so that would be 9. If this is 6 and 8 here, that's 14. This is 3, 5, 7, so this would be 1, which would make this 6 in value, so that would be 8. We haven't got anything yet for 11 or 13. So you could have 5, 6, or 5, 8 for 11. And you could have 7, 6 for 13. Okay. So those are that restriction. Oh, that's interesting. Okay, that's an interesting aspect. So Z has to match this. So whatever this digit is cannot be here. But that works for 1, 2, and 9 perfectly fine. It also works for 8 there, right? Because if this is 8, this is 6, that's 14, so this is 6, 8 there. Okay. So, if Z is 5 or 7, that means Z has to be here. Huh. Interesting. Hmm. So if Z is 5 or 7, Z has to be here. Which means Z has to be one of those two, which means Z cannot be here or here or here. So Z would have to be one of those two. That doesn't really tell us very much, though. If Z's 1 or 2, obviously it's along here. So then Z would have to be there. Z can't be here or here or here. It'd have to be one of those two, which doesn't help us anything for restricting things. Hmm. Not really sure where to go to next with this next thing. I'm trying to find ways to restrict the path, but I can't really figure it out. We do know that P has to go to one of those two. We know F has to go to one of those two. Sorry, P has to go to one of those two. But it's not that restrictive, unfortunately. Where else can we go? Because this is a lot of open spaces that F can go to. P is restricted in that she can only go here, then here. But even that's still pretty wide open, right? Can F ever go from here to here? If F goes from here to here, P would have to come from this angle. Because obviously, well, what happens if this is booster? That's 4 and 6, so that's 10. So that's not going to match any of the cells that would be here because this would be booster, so none of these would be booster. And for P to come in, she would have to come in from that side. So this could not be booster in that case if she comes in that way. So if F comes in this way, P has to come in this way. Oh, the different digits in the booster cells. This can't be 1. So then we know this is 3. Therefore, this is value of 8. This must be 4 because we have 1 in a booster cell already. That's why. So that's good. We have 8 there. This can't be 8. You cannot have 9 here. So we have 1, 2, 5, or 7 here. That's good. Okay, that helps a lot. So no 4 here, no 4 here, no 8 wrong this row. 3 cannot be here. So the sum of this must be 3 with another digit. So 3 with another digit cannot be 3, 5 because of this doesn't add, this adds up to this scenario here. 3 and 6 add up to 9. So we have 9, 10, and 11 as possibilities. Cannot be 11 because that would be 8 and 3 trying to add up. So this has to be 1 and 2. Interesting. Okay, so this is Z is 1 or 2. That helps a lot, actually. This cannot be 3 and 8. So it must be 3 and 6 or 3 and 7. So either way, 3 is here, which means this cannot be 3. This can't be 3 here. We have a guaranteed 3 here. So 3 cannot be any of these cells. This can't be 8. No 3 here. So 3 has to be one of these 4 digits here. 8 is here, so this can't be 8. So can this ever be booster cell? That would be 9 plus 5, which is 14, plus at minimum 2, which is 16, which would be in a 1 to 2 ratio with 8. So this cannot be booster cell, which means this is booster cell here. That eliminates booster cell in the rest of the row. So then P has to go this route. Uh, 8 eliminates 8 here. Okay, that helped a lot. I totally forgot about the booster cells have to have different digits or unique digits. This cannot be 1 and 2 in a 1 to 2 ratio because Z is 1 or 2. So this can't be 1. We can't have 6 here. It has to be 2 and 4. There we go. So that's 2 and 4 in a 1 to 2 ratio. That means Z cannot be 2. Z is 1. So that's 1 there. This is then 3 and 6 as a pair. That eliminates 3, 6 in the rest of the box. This can't be 6, so this is also 3 and 6. No 6 here, no 6 here, no 2 here, no 4 here. So we have 1 here and 2 here. This is 4. So 2 has to be one of these 3 or 4 digits here. So we have a guaranteed 2 here. 1 eliminates 1 here to match. The 2 matches one of these 4 digits. Y is here. Cannot be 9. Cannot be 3, 6. Can't be 1, 2, 4, 8. Y has to be 5 or 7. So why is 5 or 7 there? 5, 7, 8 as a triplet in row. Let's remove these. Remaining digits in row 8 are 2, 3, 4, 6, and 9. Well, 2 and 4 cannot be here. 3 and 9 cannot be here in this booster cell because they are already in other booster cells. So this must then be 6. This can't be 6 or 3, it's 9. That means this cannot be 6 or 9 here. 3 eliminate in the column eliminates 3 here. So this becomes a 5, 7 pair here, which eliminates 5 and 7 in the rest of the box. This can't be 5 or 7, it's 3 there. That eliminates 3 in the rest of the row here. This cannot be 6 or 9 because of the 6, 9 pair in the row. So this can't be 3 here. This is 2, 3, or 4 here. This can't be 6 here. It's 5, 7, or 8. All of which eliminates y from being here. So this must be y here as 5 or 7. So that means f must go this route. 1 here eliminates 1 here, so that's 2 and 1. So therefore, f has to go this route. We have 5 and 7 to 2, which cannot be here anymore. So there's no 2 here. We are guaranteed a 2 there. Can't be here either. So 2 has to go to one of these. Oh, adds up to... So 2 is guaranteed here. It adds up to 9, so this must be... this can't be 2. So this must be 2 here, and it must be with 7. So then y has to be 5 here. Which makes this 5. And that makes that 7. Okay, we can delete a lot of things there. So must go to 2. Can we go to 4 here? I think the answer is no. If we go 4 here, we have to go 1, 2 at 3 at minimum. 4, 1, 2, 3 does not reach the cupcake. So we cannot go to 4. We have to go to 9. So we go to 9 there. Can this be... So we cannot go this route. Can we go this way? 9, that's 1, 2, 3 also. 1, 2, 3, again, does not reach the cupcake. So we can't go 9. Even then, it would have to be 9 with 18, and none of these are going to be 18. So no, cannot be 9 here. 9 has to go to here. This is 4 and 6 anyway, so that's 10, so I can't reach there. If we try to go 9 there. Okay, remaining digits in box 2, we have 6 and 9. 6 can't be here because of 6 in the column, so that's 9, which makes that 6. So this cannot be 6 here. Okay. We don't need A and Z or Y because we know everything where that is. This can't be 5. 7 eliminates 7 from the rest of the row here. Remaining digits in row 9 are 1, 7, 8. Okay. 2 can't be here because of 2 in the column. 4 can't be here because of 4 in the column. Do we want to clear this? Yeah, this isn't helpful right now. Remaining... Okay, so 9 cannot go here. So remaining digits here in column 4 are 2, 5, and 6. Remaining digits in column 5 are 1, 7, 8. Remaining digits in column 6 are 3, 4, and 9. Okay. So if this were... So if this is not a booster cell, it can't be 3. It has to be 4. If it is a booster cell, that's 6 and 4 and 6 adding up to what that digit. 13 is not going to be in a 1 to 2 ratio with any other digit. So it'd have to be 4 here. So this is 4 either way. So this is 4, which makes this 9. So that's not a booster cell. That eliminates 9 in the rest of the column. So that's 5, which makes this 6, which makes that 9. 5 eliminates 5 in the rest of the column. So this is 9. These can't be 4. It's 3 and 9. As a booster cell, so if this is 4, then it has to be 8 here. If this is 4 with a booster cell, it's 14, which would be in a 1 to 2 ratio with 7 or 8 here. We need access to a 9. So it has to go here. So then this F must go this path. Oh, which means she's taking a long way around to get to here. Okay. F then has to go here, here, definitely. So this is 9. Remaining digits of row 1 are 1, 2, and 4. So she could go 4 here. Cannot go that way, cannot go that way. Wait, can't go this way. If she goes 4, then... Oh, she could. She could go down. Well, remaining digits in row... So this can't be 4, this can't be 2, this can't be 1. So she must go to 2 or 4, which is one of those two. Remaining digits in row 2. We have 3, 6, and 8, with one of these being 8. Remaining digits in... Okay, so cannot go through both of these. Or actually could potentially. Remaining digits of row 3. We have 3, 5, 6, 7 as possibilities. Okay. Or could be 9. Remaining digits of column 1. We have 1, 2, 4, 7, 8. Okay. This adds up to 9. Can this be boosted then? That's row 5, column 2. And the minimum, no. So the answer is no. 5, 7 plus 1 and 3 is at minimum. So this cannot be boosted. Which means this adds to 9 by itself. Okay, so 3, 4, 5, 6, 7, 8 with 1 through 6 here. No 4 or 6 here, which means this can't be 3 or 5 respectively to add up to 9. Okay. Can we do full across here? The answer is no. I don't think. We would have to go... So if we try going this route, 2, 4, this can't get to 1. 2, 4, 1. So that doesn't work. It can't reach 1 here. We can't... No, we can't even... We have to get this way. So we can't even go down. We either go here, around that way, or we go through here. If we try going... So if we try going all 3 here, 4, 1 doesn't work because we can't reach a 2. So we cannot go this route. We have to go that route. Interesting. So we have to go that way. What? Okay, so one of these is guaranteed to be boosted. That means we have to reach another boosted cell because this is going to be at minimum row 2, column 8, which is 10. So one of these is going to be boosted, which means we have to reach a boosted here. So if we go 2, 4, so we get 2, 4, that's 1. 2, 4, we have to get to something and then boosted. Or we go 4, 1, and then that's boosted. Wait. Yes. So either one of those potentially works. What happens if we go this way and then go to the boosted there? This would be boosting of 6. Okay. Let's just do remaining digits in column 2 for now. There's going to be a lot of them, though, but whatever. 3 through 8. No 4 here because of 4 in the row. Okay, if we go this route, then it would be 2, 4. Oh, it can't be. One of these is 3. So we cannot go this route. We have to go 4, 1, and then boosted. Okay. So we need 4, 1 boosted. That makes this 4, 1, and 2. This is boost. So this is boosted, which is what? 9 and 2, 11. 11 plus at minimum 7 is 18. So this must be value 18. Therefore, it must be boosted. This can't be boosted here. There's no boosted here. This is boosted here. Because one of these two is going to have to be boosted. We can't go that way. We have to go that way. Okay, so P goes that way. So that must match that. So this is 4, this is 1. There's no 1 here, no 1 here, so this can't be 1 and 8 adding up to 9. So we have to reach here. That must match that, so this is 3. So we have 3 here. This is 3 here, which makes that 2, which makes that 4. And this is guaranteed to have to be boosted because it must match. One of these has to be boosted. It can't be the second one. 3 eliminates 3 here, so that's 6 and 3. 6 eliminates 6 here, so that's 8. 8 plus 2 and 8 is 18, which makes that a 7. That's 8. We knew that anyways because we already have a boosted cell with an 8. So this is not boosted. One of these two is boosted. 8 eliminates 8 here, so that's 7. No 7 here or 7 here. 7 can't be here, so this can't be 2 to add up to 9. No 3 here or 7. No 3 or 7 here. This can't be 4, 7, or 8. This is a 1-2 pair. One of them's boosted, and it has to be the 2. Which is, so we don't know which one is which. Okay. So we have a 2 boosted here. We cannot have 3 and 9 boosted here. So this must be 4 boosted because we have 3 and 9 already as boosted. So these are not boosted here. This is 4, which is adding with 6 and 4. To add up to 14, which is 1 and 2 ratio with 7. So no 7 here, no 7 here. Remaining digits in column 3. We have 3, 5, 6, 3, 5, 7, 8. This can't be 7. Where is the 7 in box 4? It has to be here. So this is 7 guaranteed there. These can't be 3 because of 3 in the box. So we have 5, 6, or 7 we must get to. And we can only reach the 6. So this must reach 6, which means this is 6 here. That means these can't be 6 here. Could go that way, that way, that way. Remaining digits, 8 can't be here because of 8 in the column. We have a 5-7 pair now in column 8, which eliminates 5 and 7 in the rest of the column. Where is 1 actually in row 4? These can't be because we have a 1-8 pair here and a 1-2 pair here. These can't be because of 1s in the columns, so 1 has to be here. Remaining digits in column 8, or actually let's do 9. We have 5, 7, and 8. Okay, this can't be 7 because of 7 in the row. Remaining digits in column 8. We have a 5, 7 pair here, so that means what? We have 3 and 6, 4 and 9. 4 and 9 cannot be here because of a 4, 9 in the row. So we have a 3, 6 pair also in column 8, which eliminates 3 and 6 in the rest of the column. So this becomes a 4, 9 pair here. Okay. So this 6 can go to 5. Well, this could also be. Oh, this can't be. This cannot be. What is it called? Booster cell. Because well, we have a booster cell in the row. What are we missing as a booster cell? We're missing a 5. So one of these two has to be a 5, which means this cannot be 5 here. That's 7 or 8. We also have a 2 there. Okay. So F coming in must come from one of these two cells. P coming in must come from one of these 3 cells for the cupcake. So they must match, essentially. Remaining digits of column 7. We have 2, 3, 6, 5, 7, 8. That's pretty broad. This can't be 7 because of 7 in the row. This can't be 7 because of 7 in the row. These can't be 5 because 5 is guaranteed to be in the booster cell, but we don't know which one it is. Seven has to be one of these 2 digits there. Okay, so we still need to figure the path. Oh, she could go here as 7. So P could go this way, or this way, or that way. Can she go that way? Well, How many steps for F to get to the cupcakes? One of these is a 3. If we try going 7 there, that means we would have to go 7 there. We cannot reach the 1, so we would have to go that way. So either way, we're coming from this spot. We can't ever get through the 1, right? 7, well, no. Well, we could go 7 this way and then 1. That's potentially the case. What happens if we do that? If we go 7 here, then 1 here, we can only delay 1, 2, 3. 1 to 8. We can't even go there. So if we try going 7 to 1, it would be 7 to 1. We would have to go here. 3 and 9. Go 3 here, but then we would have to go to the cupcake. That's not well, we go 3 here. If we try going 8 here, then the cupcake, the problem is it doesn't reach there. It has to either, there's too few steps. So we cannot go 7 here with going to the 1 there. We could potentially delay going this way, right? Um... Hmm. Hmm. So if we go directly here, we can't get to 9 because there's no 9 here. We can't go all the way down for F because it's going to be one of those has to be a booster cell, which would be at minimum 9 plus 5, which is 14. And then P can't reach a booster cell at all. Hmm. Can we go this way is kind of the question. So we have 7, 6. It would have to be 7, 6 there. Oh, this must match these two. So we have 7. Okay, that's helpful. 9, 3, and 6. So that helps a lot. 9, 3, and 6. This has to be 7 then. So that makes this not 7. That's 5. That's 8. So this can't be 8. That's 5, which makes this 7 there. Okay, that helps a lot. 7 eliminates 7 here, so that's 5 and 7. 3 eliminates 3 here, so that's 6. No 6 here then. 6 eliminates 6 in the rest of the row. This is 7 to 5 to 8. So 5 cannot be here, that's 8. This can't be 8 here. This can't be 5 or 8 here. It's 4 or 6. 7 is there. Oops, how did I want to delete that? Okay, so this can't be 5 or 8. It's 4 or 6. 5 eliminates 5 here. 5 is the booster cell, so this can't be booster cell. This can't be booster cell, so this must be booster cell here, and it's 2, which makes this 1. This can't be 1, so that's 8 and 1 there. 2 eliminates 2 here. 8 eliminates 8 here. Okay. This can't be 8 because of 8 in the row. We have a 2, 3 pair in column 7, which eliminates 2, 3 in the rest of the column. So this is 8. This can't be 2. Okay. So 6 has to access 7 or 6. Can never access 1. So has to get through 6 somehow. So it could be 7, 6 or 7, 6 or 6 straight. Going 6 straight. If we go 6 straight here, that means we have to get to 4, which would be 4 here, but that would be a contradiction. So we cannot go directly to 6. Can we even go this route? If we go 7, then 6, it would be 7, 6 here. This would necessarily force to be here, and it would be 4. But this would have to go there to be the 4, and we'd have a duplicate 4 in the row. So we cannot go this path. We have to go this way. So we go 7 here. That means F goes 7 there. The only other one now we can go is 6. So that must go 6 here. So this must be 6. So that's 6, which makes this 4, which makes this 6 and 3 to add up to 9. This can't be 3, it's 5, which makes this 2, which makes that 3 and 2. 6 eliminates 6 here, so it's 5. That leaves this 3 eliminates 3 here, so it's 9. That leaves this as 4 and 9 there, and that's going to be a 3. But we need to figure out the paths. We have 6 here can get to 3, 4, or 1. 6 here can get to 3 or 1. So this 6 cannot go that path. What happens if we go 1 here? It's going to be very far to get there. So 1, from 1 we have 5, 8, or 3. From 1 here, it would have to be 7. So we cannot go 1 here. We must go 3 here. So this must be 3 that way. We can't go 3 that way. We can't reach 3 here, so 3 has to go that way. And 8, 3 goes to 8 necessarily, which means 8 goes that way. And we cannot go to a 2 from here. We can't reach 2, so this must, and they can't go 3 here because they would have to go to the same 3. So therefore, it must go that way, and it must go that way. And that's the solution. Experiment completed successfully. Test date, March 18th, 1975. Cells visited, 47. Black currants eaten, 1. Starfruit eaten, 3. I've noticed a few interesting moments that have occurred during the most recent tests. Sometimes P will pause and look toward her friend, as though wanting to be helpful and guide her in a particular direction. F, however, will continue on independently, preferring to work things out for herself and appearing almost resistant to any guidance. These exchanges are subtle, but suggest that their partnership is still evolving, shaped as much as by a desire to assert individuality as by collaboration. Pretty cool, actually. It was interesting how the restrictions of the paths made things. I did forget about the booster cell, and if I had, that would have made things much easier. As it flowed very much easier once I realized that, right? So that would have been good to know or good to focus on before, but sometimes you forget about rule sets. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.